Hey y'all, welcome back. On tonight's homework, we will be working with rational numbers. We will order and compare rational numbers. We'll use the order of operations with rational numbers, and also use rational numbers to solve real-world problems. So first, let's just make sure we understand what a rational number is. Generally, a rational number is going to be written as a fraction. But as we saw in the previous lesson, we could also represent rational numbers using decimals and percents. So let's start with this first problem where we're asked to compare two rational numbers. First, we've got negative 2/4 and negative 1/4. And what I would recommend is that we convert these to decimals if you just want like an easier way to compare these. Negative 2/4 is the same as negative 0.5. And if you're not sure how to convert these to decimals, just throw it in your calculator. Do 2 divided by 4, and you get 0.5. Negative 1/4, if we put that in the calculator, we'll get negative 0.25. Now with this number line, you really shouldn't need to convert these, but I want you to kind of see how you might be able to compare these just in case you don't have that number line handy. So negative 2/4 is right here. Negative 1/4 is right here. And we know that negative 1/2 is smaller than negative 1/4. So however way you want to think about this, negative 2/4 is smaller than negative 1/4. If we're comparing 3/4 to negative 2/4, well, first of all, 3/4 is positive. So that is for sure going to be bigger than any negative number I can throw at you. We can find negative 2/4 right here and 3/4 right here. So yeah, 3/4 is going to be bigger. Lastly, we've got negative 1/4 and 0. Well, negative 1/4 is negative, and all negative numbers are smaller than 0. But we can see we've got negative 1/4 here and 0 here. So we can see pretty clearly that negative 1/4 is smaller than 0. Number 2 says which numbers are rational, and this is really just about understanding what a rational number is. It's a number that can be written as a fraction of whole numbers. So if I can't do that, then it's not rational. Negative 19 is a number that can be rewritten as negative 19 over 1, so that's rational. Negative 2/5 is already written as a fraction, so we're good there. 0 could be written as 0 over 1, so we're good here. Now pi, you might think, oh, pi over 1, that could be written as a ratio. But in order to really be a rational number, both the numerator and the denominator need to be whole numbers here, or integers rather. So since we can't do that, pi is not going to be a rational number. That is going to be irrational. 4/7 is rational. Square root of 7 is not, and most of the square roots will not be. The only square roots that will be rational are perfect squares, like square root of 16 is exactly 4, which we can write as 4 over 1, so that's going to be rational. Any decimal that you can write out is also going to be rational, and that's whether it's terminating like 2.89 or repeating. Both of these can be written as fractions. 2.89 can be written as 289 over 1,000, and 0.3 repeating is simply a third. So you can see we can write all of those numbers as a ratio or a comparison between integers. Number 3 is asking, which one of these number lines has negative 0.7, 0, and 1/4 plotted correctly. So let's start with 0. That's the most obvious one. Make sure we got that plotted right. Okay, so it looks good on A, looks good on B, looks good on C. So we're not really going to use 0 to help us out there. Now let's look at 1/4. 1/4 should be a quarter of the way to 1. Well, on that first, on A, we've got a point, but that's at 1/2. So it's not going to be A. On B, we've got a point halfway in between 0 and 1/2. That's going to be 1/4, so that's good. We can go ahead and say, oh, that might be our answer. And for the last one, for C here, we've got a point halfway between 1/2 and 1. That's going to be at 3/4. So yeah, it's not going to be C. So really, we can already say that it's B here, but just to make sure, we've got negative 0.7, and negative 0.7 is going to be in between negative 0.5 and negative 1. So we see that right here. That's going to be our negative 0.7. We got the 1/4 here. So our answer is for sure B. Number 4 is just a series of comparison statements that we need to say is true or false. Negative 2.5 is the same as negative 2.5. You can always throw that in your calculator if you want, but 1/2 is the same as 0.5. So this will be true. For B, negative 1.5 is not bigger than negative 0.5. With the negative numbers, if you look at like how far it is away from 0, those are going to be the smaller numbers, unlike positive numbers. So this is false. Every negative number will be smaller than 0, so C is true. Negative 2.5 is less than negative 2 for the same reasoning we talked about in part B, so this is going to be true. 1.5, that's the same thing as 1.5. That is not bigger than 1.5. It's actually equal. We could look at letter A as a similar problem. This is going to be false. For number 5, it says Meg used this table to track the average attendance from month to month at her theater for 5 months. Fill in the blank correct with the correct inequality symbol to complete each statement. Plot and label each month on the number line. So again, we're just comparing the numbers that we see in the boxes there. It might help to put each month on the number line so we can clearly see which one's bigger. So October is at -1. Okay, so I'm going to just put, I don't have a ton of room here to put it, but I'm going to say, okay, here's October. How do I want to write this? Maybe I'll just put October here. November is at 0.5, so I'm going to put November over here. December is -0.9. That's just shy of -0.1. So December is like right here. January is at 3/4. That's the same as 0.75. So we got January right here. And February is 1/2. We'll be at the same place as November. So if we're comparing November and December, we can see that November is to the right of December. Right? November is over here. December is way back over here. So November is the bigger of the two numbers. So November is greater than December. October is a little bit less than December, not by much, but you can see that -1 is slightly to the left of -0.9. January and November. January is further to the right, 0.75, which is 3/4, is larger than 1/2, which is 0.5. So January is going to be the bigger of the two. As far as defining these terms, whole numbers, integers, and rational numbers, whole numbers are the set of counting numbers and zero, so no negatives when I say whole numbers. Integers, which are the numbers that we use to construct rational numbers, are all the whole numbers and their opposites, so all the negatives. When I say the opposites, what I mean is their negatives. And finally, rational numbers, which is what this whole unit is based on, are these numbers that can be written as fractions. They can also be written as decimals as well. Number 7 has a little diagram to show the how whole numbers, integers, and rational numbers are related. Basically, what this is saying is that all whole numbers are integers, all integers are rational numbers, but not all rational numbers are integers, and not all integers are whole numbers. So whole numbers being like 0, 1, 2, 3, etc. Integers are all the whole numbers, but also their opposites, so the negatives as well. Rational numbers are any number that you can write as a ratio of integers. So we have all the integers, right? We've got all these counting numbers and their opposites, but we also have ratios of all these numbers. So we have things like 1/2, 1/3. You could write these as decimals, 0.5. Even the negatives, -1/2, -1/3, 1/4, etc. So 7 says, which statement is correct? A says -5 cannot be written as a fraction, so it's not rational. That's just plain false. We can write that as -5/1. Number 5 says -5 is a rational number. That's true, but not an integer. That's false. It is also an integer. So this part's true, but not this part. -5 is a counting number, so it is a whole number. No, not true. I know it's kind of weird counting numbers, but we really only count the positives and 0 when we're counting from 0. So yeah, it's not a whole number. And finally, -5 is an integer, but not a whole number. Wait a minute. That's not true. Maybe I overlooked one. Hold up. -5 cannot be written as a fraction, so that's not true. Okay, -5 is a rational number, but not an integer. It is an integer. -5 is a counting number, so it is also a whole number. -5 is an integer, but not a whole number. Well, none of these are right. Wait a minute. Yeah, there's none of the above, I guess. We'll just go with E here. None of the above. -5 is an integer, a rational number, but it's not a whole number. Oh, wait a minute. I totally misread that. Oh, I'm sorry, y'all. My bad. So, yeah, D is correct. It is an integer, not a whole number. It's not a counting number. I just totally misread that. That's my bad. It belongs here, not down here. All right, Mr. Schuler, let's try to pull it together for the next one. Number 8 says, which sets of numbers contain only whole numbers? Okay, so these are counting numbers, including 0. No negatives. So no negatives, we can eliminate A and C. Also, no fractions. Okay, so 1/8 is out. It's just going to be B. Number 9 says label each point as either 0.5, -1/2, -1.4, or 2. So 1/2 is going to be halfway between 0 and 1. So 0.5 is right here. -1/2 is going to be in between 0 and -1, right here. -1.4 should be just shy of -1.5, so that's going to be right here. And 2 is all the way over here. It's already labeled, so I don't really know why they ask you to label that one. And so there's 2 points that are just not labeled, but the directions say that not all points will be labeled, so I think we're good. Number 10 says label each point as either -1.6, -0.3, -3/4, or -1 1/4. So here we have a vertical number line, which you don't use too often, except when you start graphing functions, you have that vertical y-axis. So you really do start using a vertical number line. It's just typically when you just have one number line, you don't write it like that, usually, but you will once you start integrating some y-axes into our graphs. So -1.6 will be a little bit further down the line than -1.5. So I'm going to put that right here. -0.3 is going to be before -0.5, so -0.3 is going to be about here. -3/4 is like -0.75, so it's 3/4 of the way to -1. That's going to be here. And finally, -1 1/4 would be -1.25, and that's going to be right here. 11, we were going to plot and label all these numbers. So -1 2/3 is going to be right here. So this is -1 2/3. -1 1/3 will be right here. I guess I'll put this underneath just so it doesn't get too crammed in here. -1.5, well, geez, this is really kind of getting crammed in here, but -1.5 should be right in the middle here between -1 and -2. And then 0.5 is going to be out over here. Oh, wait a minute. That first one isn't 1. I didn't read that close enough. 1 is here. It's got to be halfway. There we go. So right here, we've got 0.5. Number 12 says which inequality is true. And again, we're just comparing these rational numbers. -1.5 is smaller than -0.5, so it's not A. All negative numbers are smaller than 0, so it can't be B. -2.5 is less than -2, so it looks like we've got our answer. But let's check the last one. The last one says that a negative number is bigger than a positive number. That can't be true. All positive numbers are bigger than all negative numbers. So yeah, the answer is definitely C. Number 13 says a biologist recorded the change from average water levels in a local pond over 3 weeks. Using inequality symbols, order the 3 weekly water levels from least to greatest. So the smallest number on here is going to be week 3, -2.1. Then the next one is between 1.4 and 1.5. Well, 1.5 is 1.5. So the 1.4 is going to be slightly smaller here. So here we go. And maybe I'll just go back and actually write it the way it's written, 1.5. So now we've ordered them. And now we want to plot them on the line. So week 1 at 1.4 is going to be roughly right here. Okay, so here's week 1. And then week 2 at 1.5, well, that's going to be like right next to it, isn't it? So that's going to be right here on that dot. That's going to be week 2. And then week 3 is all the way over here. Number 14, we've got a lot of order of operations here, and for the most part, you're just going to type these into the calculator. You're going to get a calculator for the TSI A2. So we might as well just go ahead and use them. I don't really want you to do any of this by hand. There's only one thing that you're going to have to really look out for, and that's on D and E, and I'll talk about that once we get there with the absolute value stuff. So A, I'm just going to type this in directly. There's not really a lot for me to expand on here. I'm typing just the whole thing. So negative 7.6 minus 2 times in parentheses 9 plus negative 6.8. And I would just type this in exactly how it looks. You should get negative 12. For B, take advantage of that fraction button. If your calculator's got a fraction button, making sure you're using it. 2/3 divided by negative 4. And I'm just typing this in exactly how it looks. Minus 1/6 minus 8/6. And I get 1. Well, that works out pretty nicely. For C, I've got 8.3 minus 4 1/5. Now, this might be a little tricky to do in a calculator because most calculators are not going to let you do an improper a mixed number like that. So let's just rewrite this as 4.2. So 4.2 times 6.1 times a half. So I got negative 4.51, or if you've got like a fraction, if it reports the number as a fraction, it's going to be 451 over 100. I don't care. You could write it either way. I'd be good either way. Wait a minute. Hold up here. I just realized I had a typo. I typed in times 0.5 instead of plus 0.5, so we're going to have to change that. Plus 0.5 is going to give me a totally different answer here. Let's fix that up. I apologize, y'all. Okay, but that's just, it goes to show that you really got to go back and double check your work. Make sure you type everything in correctly. Otherwise, you're gonna have a mistake like Mr. Schuler. Negative 19.42 is what I'm getting actually. Okay, so with D and E, we've got these absolute value bars, and I want you to evaluate those separately. So basically type in the calculator the stuff in the bars. So 5 minus 7 is negative 2, 13 minus 2 is 11. And then when you take the absolute value of a number, as we talked about in the lesson, all that really does is change that number to be positive. So the absolute value of negative 2 is positive 2. Absolute value of 11 is 11. 2 plus 11 is 13. So the only real trick here is you can't really just type the whole thing in your calculator unless your calculator happens to have absolute value bars. Most scientific calculators are not going to have those. So we'll just evaluate the stuff inside the absolute value bars first. So 29.2 minus 31.8 is negative 2.6. So I have 2 times the absolute value of negative 2.6. Minus 5 times the absolute value of, let's see here, 101.6 minus 14.7 is 86.9. And I know you can't see me doing the calculator, but I'm typing these in as I go. All right, so since the absolute value changes the number to positive, we've got 2 times positive 2.6 minus 5 times positive 86.9. So if that number inside is already positive, the absolute value just really does nothing. So 2.2 times 2.6 minus 5 times 86.9. All right, well, I'm getting a number like negative 429.3. Number 15 says Mary brought $20 to the skating rink. She paid $5.50 for admission and $3.75 to rent skates. She also purchased 2 bottles of water for $1.25 each and a snack for $2.75. How much money does she have left? So she started with $20, and then she bought a bunch of stuff. So we need to subtract all of those values that she paid for. So she paid for $5.50 admission. She paid $3.75 to rent the skates. And she bought 2 bottles of water, so 2 times $1.25, and a snack for $2.75. So we just need to subtract here. We're going to do 20 minus 5.5 minus 3.75 minus 2 times 1.25 minus 2.75, and that gives me 550. Number 16 says Sabrina purchased 3/4 pound of apples, 1/2 pound of nuts. What is the total cost of these items to the nearest cent? So we have 3 3/4 of a pound of apples, and apples cost $2.49 a pound. So we're going to multiply that by 2.49, and a half pound of nuts. So 1/2 times the price of nuts, $7.98, and that should give us our total price here. So we got 3/4, which is 0.75, times 2.49, plus a half, which is 0.5, times 7.98, and we are going to round to the nearest cent. So we get approximately $5.80. We'll round up that last decimal place to 86. Number 17 says a movie theater in town posts their prices for tickets and snacks. Sally and Ann went to the movies. They each purchased a drink. They also bought 1 popcorn and 1 veggie cup to share. Okay, so altogether, just to break this down, they each purchased a drink. So they're going to have 2 drinks. So that's 2 times the cost of a drink, which is $1.35. You can see that in the table right here. Then they bought 1 popcorn and 1 veggie cup to share, so just 1 of each. So 1 popcorn is $3.50, 1 veggie cup, $1.74. So the total amount is just going to be what we get here when we multiply and add all this up. 2 times 1.35 plus 3.5 plus 1.74 is $7.94. Part B says when the movie's half over, popcorn sells for half price. Determine the cost for purchasing 3 orders of popcorns and 2 veggie cups when the movie's half over. So 3 orders of popcorn, so 3 times half price. So if the popcorn is $3.50, we'll do $3.50 divided by 2. Okay, we can let the calculator tell us what that is. It's going to be $1.75 if you can figure that out, but we don't have to. We can let the calculator do that. Plus 2 veggie cups. So 2 veggie cups. It doesn't say that veggie cups are on sale or anything, so we're just going to charge the full amount for the veggie cups. And then we're going to type this in. 3 times half of $3.50, which is $1.75. Or you could just type it in as a fraction as well. Either way works. Plus 2 times $1.74 gives us $8.73. Number 18 says, yesterday, the movie theater brought in $1,440 in ticket sales and $295.25 in food sales. Today, ticket sales were 3/4 as much as yesterday, and food sales were down by $33.50. Determine the total amount of today's sales. Okay, so yesterday, we had $1,440 in tickets sales and $295, and a quarter in food sales. Today, we have ticket sales are 3/4 as much as they were yesterday. So 3/4 times 1,440, which is $10.80. And food sales were down by $33.50. So we have that $295.25 minus $33.50. Which is $261.75. It says determine the total amount of today's sales. So we're going to add up all those sales. So the total is going to be the sum of the $10.80 and the $261.75. So say the total for today. I can't spell today apparently. Is $10.80 plus $261.75. And so I'm getting a total of $1,341.75. Number 19, our last problem. I think, yep, the last problem. It says a certain map is a scale in which 1/4 inch on the map represents an actual distance of 8 miles. Okay, so 1/4 inch on a map is the same as 8 actual miles. A distance of m miles is represented by how many inches on the map? So m miles equals how many inches on the map? So I think the easiest way to answer this question is to figure out what do I need to multiply or really divide 8 by to get 1/4. In other words, 8 times what scale factor, I'll just call it x for now, equals 1/4. And so the way to get that is to divide both sides by 8. And so we get 8, 1/4 divided by 8 is going to be 1/32. So this is going to be the scale factor to go from 8 miles to 1/4 inches. So over here, I've got m miles times 1/32 gives me m/32 inches. So our answer here is A. And that's it for tonight. Please reach out if you have any questions on any of these problems. But otherwise, y'all have a great night, and I'll see you next time.